Okay, so we're going to be doing the signal flow graph. So, assuming this is a signal flow graph here, we have our points 1, 2, 3, 4, 5, 6, 7, and 8. Now, in this flow diagram now, we have feedback points here from 4 to 3. Look at this, you can see the direction of the forward paths indicated by these points here, showing that it's flowing forward. There's also another point from this point to, it splits down this way and joins back here and flows forward. So in your signal flow diagram, you have your forward paths. Let me write it down, give me a minute. Okay, there are three types of paths. We have our forward paths, our individual loops, and our non-touching loops. Now the forward path is the path which the signal flows from this end to this other end, from point 1 to point 8. So it can either, let's face each of the paths individually. So let's start with the forward paths. So when we're talking about forward paths, let me write something in a minute. Okay, so when we're talking about forward paths, we're looking for the path in which the signal flows from point 1 to 8. So we can say one forward path is 1 to 2, then to 3, to 4, to 5, to 6, to 7, to 8. Along this path is a forward path. Another forward path we can say, instead of going direct, we can go 1, 2, split off at this junction, we get to 5, 6, 7, 8. Okay, now from your knowledge of your block flow diagram or your signal flow graph previously, you'll see that each of these, the distance between here to here has a figure. This beginning figure is represented by 1, here is represented by G1, represented by G2, this is represented by G3, represented by G4, represented by G5, this is represented by 1. So, sorry, assuming I want to write the forward path for this line, I'm going to write it as this times this times this times this times this times this times this. Let me write it down. Okay, so our forward parts, one of our forward parts, let's say this is our part 1, be 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8. This is a better representation of that. We have 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8. The distance of each part is represented by this 1. At the beginning we have 1, at the end we have 1. The rest is G1, G2, G3, G4, G5. That's why we now write it here. This G1, 1 times G1 times G2 times G3 times G4 times G5 is our part 1. Then we also have a second part, which is part 1 to 2, and we follow this curve here to part 5 to 6 to 7 to 8. And that is what we write as our second part, 1 to 2. We follow the curve to part 5 to 6 to 7 to 8, which is 1 times G6 times G4 times G5 times 1. Okay, so moving on, we also mentioned that we are done with our forward parts. Now we are looking at our individual loops. Now our individual loops are, let me explain what a loop is. Now a loop in the signal flow graph is where the direction is flowing backwards. So you see this here, it goes forward and it flows backward. This is a loop. Flowing backward, this is a loop. Between these points is a loop. And at here, we're going forward and we're flowing backward, so that is a loop. So when you're talking about your individual loops, we're talking about, aside from the main forward parts, that is flowing straight and following this curve, the loops are this, this, and this. Let me write it down properly. Okay, so now we are talking about the individual loops, which are these, between 3 to 4 and back to 3, 3, 4, 5, and back to 3. Then we have 6, 7, and back to 6. These are individual loops. Let me represent them. Okay, so our individual loops, we have the first one, 3, 4, and back to 3. This is our first loop. And to get the gains on this part, this is our this times this, the distance between them, that is g2 times minus h1. We have here our p11 is minus g2 h1. For our second loop, which was 3, 4, 5, and back to 3, the same thing. To get the gains, we have g2 times g3 times minus h2 to give you p12 is equal to minus g2 g3 h2. And lastly, our third loop, we have 6 to 7 and back to 6, that is g5 times h3 times minus h3 to give you minus g5 h3. Next, we're going to talk about our non-touching loops. Okay, so we're done with our individual loops. And now, from our individual loops, we know that we have 3 loops. So we're going to talk about our non-touching loops. Now, the non-touching loops are the loops that do not touch each other. So we have this loop, and this loop. Between the 3 of them, which pair do not touch each other? This loop and this loop, they don't touch. This loop and this loop, they don't touch. So these two pairs are non-touching loops. Let me write it down to make it clearer. Okay, so for the non-touching loops now, we have our 3, 4, 3, 4, and back to 3, and 6, 7, and back to 6. These two loops do not touch each other. So we're going to do the gains here, and that is minus g2 h1 times minus g5 h3 to give us this value. This is the gain on the first non-touching loops. Okay, so the next non-touching loop is 3, 4, 5, then back to 3, and 6, 7, back to 6. To get the total gains here, you do the gains here, which is g2 times g3 times minus h2, should give you this value, times g5 times h minus h3, which is this value. So you're multiplying the gains on both individual loops to give you the total gains on the non-touching loop here. So this is our second non-touching loop. These are the only two loops in the... So these are the only two pairs of non-touching loop, which is this loop and this loop. This is one pair, they are not touching each other. And we have this loop and this loop, they are not touching each other. Now, like the block diagram, we are trying to find the transfer function, and the formula for the transfer function is equal to CS over CR, to your output over your input, is equal to P1. Remember that our P1 is the forward path times delta 1 plus P2 is the second forward path times delta 2 over delta. Now, delta 1, delta 2, and delta each have their own formula. So we have delta 1. Delta 1 is 1 minus the loops not touching the first part. That is any loop that is not touching the first part. So these are all our loops. These are loop 1, loop 2, and loop 3. Now, if you look back, all of these loops are touching the first part. Let me go back to the main diagram. All of these loops, this is here, here, and here, they are touching the main forward part. The forward part 1, all of them are touching. So the number of loops not touching forward part 1 is 0. So we can see the number of loops not touching forward part 1 is 0. 1 minus 0 is equal to 1. Then the next delta 2, 1 minus number of loops not touching second forward parts. Now, if we go to our this is our second forward part. We have 1, 2, we follow here, and 5, 6, 7, 8. Now, this loop touches our second forward part. This loop starts just at here, that means it's also touching the second forward part. But this loop it's not touching this line at all. This line from here going like this loop doesn't touch it at all. So this is the only loop we're going to be considering. When they say loop not touching the second forward path, we're talking about this loop here. So let's go back, and the loop we were talking about was our loop 1, that is loop 3, 4 and back to 3, which has a gain. This is the gain here. The gain is minus G2 H1. So let's write that down. That is minus 1 minus bracket minus G2 H1. That is 1 plus G2 H1. So we have our delta 2. Next thing we're going to look for is delta. Now, delta is 1 minus the sum of the individual loops plus the sum of the non-touching loops. This minus only affects this bracket here. I just need to clarify that. So now what we are going to do is, let's go to our individual loops. So the gains on each individual loops, if we're summing all of them, we're doing P11, which is this, plus P21, which is this, plus P31, which is this. We're going to sum the gains on all individual loops. So we're going to have minus G2 H1 plus minus, this is plus, there's supposed to be plus, that is adding the next loop, minus G2 G3 H2. Since it's minus, plus times minus will give you minus. That's why this minus is here. That's why I had to cancel it out. Okay, and again plus the next sorry, the next loop that will be added is minus G5 H3. Plus times minus will give you minus. This minus is here. So this is the sum of individual loops. And the next thing we're doing is the sum of the non-touching loops. Let's write sum of non-touching loops. We go back to the gains on our non-touching loop. This is P21. This is the gain we have here. So this is this plus, we have this plus this. This is the next one, which is here. So let's add the two non-touching loop gains. Okay, so this is the sum of our non-touching loops. So what we're going to do, we're going to expand, open the bracket here, which is this minus times all this minus here, which is turning to plus. That is 1 plus G2 H1 plus G2 G3 H2 plus G5 H3 plus G2 G5 H1 H3 plus G2 G3 G5 H2 H3. Now we'll go back to our transfer function formula, which is P1, which is our first forward path, times delta 1. We have our delta 1 already, plus P2, which is our second forward path, times delta 2. We have our delta 2 already, and all divided by delta, which we just found. So we're going to put all of that into a formula. So doing that, this is our transfer function. Everything here, this is our P1. P1 times delta 1. Remember our delta 1 was, let me shift a bit. Our delta 1 was 1 here. Delta 1 was 1. So this is P1 times 1. Give it this value here. This is P2, which is our second part, times delta 2, which was 1 plus G2 H1. You can open these brackets to give you a final answer. Then this is our delta. This is our value for delta.